So class will be mainly on data manipulation, and this is the first class of the series, entire predictive modeling series, and we will start with some of the basic features of R, and then we will move on to data visualization, and after that we will move to statistics, and after that we will start with linear regression, logistic regression, and so on. So this is the first class of the series, and let us start. So today I will be using a data set of orange juice. So this is actually a supply chain mainly, or mainly a product related data set where I have three categories of orange juices that are available at a store, and not only at a store but a multiple store. And we will see how to make a manipulation with that data and how we can change the data, or mainly the functions that we have done in SAS like scan, trim, find, and we will find those equivalent in R today. And for that reason also I've told that in the group. So uh, we have come across some of the features in SAS like what are these functions like scan, trim, input, put, and what would be the R equivalent. So somebody asked me in the group, and for them I have said that come prepared with that. We will be working on that in the first day. So let me import my data set, which is the orange juice data set, and let us view that. So for viewing the data set, it is a simple command view your data set name. So here in my data set, I have something like store, brand, week, log move. So these are some of the names which you might be unfamiliar with, but these are some of the, I would say, features that are available with the product. Uh, Features, price, age, 60. Also, most of the variables that you can see, most of them are numeric, and also the name. So I'm not quite clear with what all or the uh, meaning of that variable, or somewhere like CPW volume 5 or something like that. But even being not clear, let us work with that and let us try to understand what is there in the data and how we can comprehend that. So names will give me all the column names that I have in orange juice. So it starts from store and goes on to the CPW volume 5. Structure. So str mainly gives me the structure of my data set. So here let's see. So I have stores. So stores will be here it is in integer, but I know that there are levels of store. So making it an integer won't actually give me a solution. So it will be a factor instead. So later in my data manipulation I will convert it into a factor, because it doesn't have an integer score, it is actually a stored number. So that for that reason I need to convert it into a factor. Secondly, I have brand, and here I have three levels: Dominic, Minute Maid, and there was one more level that is Tropicana. We will see that later. Week, number of week. So this is integer, that is fine because we will be working with that. Log move, features, price, age, ethnic, income, so on. I've seen some similar data for toothpaste, and in toothpaste also I have seen some of the similar variables. So what all the variables represent, I'm still unaware of that, but let us work with that and understand. So any idea what head will do? Head of orange juice? No, by default it will give only to top six only. Yeah, first 12 6 rows. So head will give me first six. So first six of all the variables, all the columns that I have, and after that tail. And so first six I know is head, and last six will be my tail. So both are actually complementary to each other. Last six. So last six will give me some last six variables of the data set, last six rows of the data set. And as you can see here, there are quite a number of rows in the data, 28,947 and 17 variables. So data set is a big one. Summary is also one of the key, or you can say a command which actually gives you a better understanding of your data set. It is a range, where it starts. So as you can see here, store I have in integer starting from 2 till 137, and it is spread across like uh, a numeric variable, a continuous numeric variable. But in case of a factor variable, it has been defined according to the number of. So number of brand which has minute made has been categorized there. So all is equal distribution, all the three brands. Let's say week. Week is also a continuous distribution, not a factor. So here also I can get a good understanding of week. Similarly, all other variables are of integer type, and for that reason, it has been uh, summarized in such form. So, uh, for example, if you come across other type of variables, for factor it is like this. For a character variable, you will come across some different thing, and so on. So we will see that. Okay. So brand actually, as I've shown you earlier, brand is actually a factor. So when you see this, all other variable type are of numeric or integer type, but except for brand. Brand is in factor. So factors means a level of those uh, variable. For example, if I have gender and I know that gender could be either male or female, and I know that there could not be a third gender. Even if I consider third gender as transgender, I know that there cannot be a fourth gender. So there has to be a specified level to it. Same thing with brand also. Brand also I know that there has to be three levels. It cannot be more than that. So that is something which comes as a factor in R. And mainly we will when we will be working with a categorical variable in R, we have to convert it into a factor. While I was working with a no, it is actually the count. So yeah, you've asked that 900, 9,647. What does it mean? It actually means that the count of Dominic brand is 9,649. So when you see the entire data set, so number of rows that I have is 28,947. And out of this, if you divide it by 3, all three brands are equally distributed. Dominic has so, Minute Maid has so, and Tropicana has so much. So this is the meaning of brand. But instead, if I would have converted into a character, the result wouldn't have been the same. So let me show you something. Like if orange juice, I convert it to brand and as dot character. Now I have converted into character, and let us check the summary now. So it is showing me character. So all the length it has shown me, but the classification or the type of summary that I was expecting to get has changed. So That is some feature of R that you need to take care of. Unlike SAS, where we have only two variables like numeric and character, and for numeric we have another subcategories like currency or normal numeric or date. In R, we have another kind of types of variable that are available. So it is not just two; we have multiple. So let me convert that factor, back to factor, and let us check the summary now. It has been again converted to the same thing. So let us proceed again. So table is actually a very good command in R, which actually summarizes your variable. So in whichever way we want. So for example, I've given table for only a week. So it will give me count of uh, each of the week. So for example, if I have week number 40 and so number of products or number of row lines associated to such a week number, then it will give me that. So here, as you see, my week starts from 40 and end till 160, and 40th week I have this much number of rows, 219 for the week number 40, for 41 201, and so on. So here mainly I have, as you can see, 161, sorry, 121 number of rows. Yeah, correct, kind of proc frequency. So proc frequency actually comes with a lot many, I would say, features like cumulative frequency or some percentage frequency and so on. But here I only have the count. So it is only a, I would say, a subset of proc frequency. So let me make it a comment here. It will only show me the count per observation. So orange juice, here I have 1 comma 3. So what would be the output? You can unmute yourself and speak, or otherwise you can uh, comment in the category section. So anyone, so today's class strength is quite high and I'm expecting answers from, okay, so here is my command. So my question is, uh, what would be my output for this command?
First row, third column.
First row, third column. So only, okay, fine, correct. So what happens is, whenever you see a data frame, there is a common understand thing that you need to understand here. So always remember that data frame, it will be row and then column. So it will be arranged like this. So this is my first row and third column. So I will get only one observation here. That is 40. So first was my first row, and third column was my week. So I've got, so here is, as you can see, third column was my week, and the week number that I have got is 40. Similarly, if I need more than one row observation and more than one column observation, I will use combination. So always remember to use combination for more than one observation if you are putting them together. Combination of so and so, and that is separated by comma. So this will give me first row, 12th row, 38th row, and 256th row with first column, third column, and sixth column. So first column was store, then third column was weight, and sixth column was price. And with this many number row. Now suppose if I want only to give the column name and not the column number, even I can do that here. I can say it like this. But always remember, unlike in SAS, R is case sensitive. So brand and small brand won't be equal. So these two won't be equal. Always remember that. So here if I check Tropicana, my brand and feature is 0 for all of them. Now,
Ankit,
yeah,
uh, can you explain line 27 again? The
line
combination of square and
27th or this, which one you said? Line number
both 24, 27.
24, 27. Okay.
Thank you.
So always remember that when I'm declaring a data frame, my first variable or the parameter that I pass is my row, and second parameter that I pass is column. So here it represent. So this part. Okay, let me explain in this way. Orange juice. If I do it like this, so this is my row. So see, this entire part is my row, and this entire part is my column. So here I'm taking combination of column. So let's say I'm using the same command. So, and I'm omitting the combination part because I want first these many rows and this many columns. So it will give me an error because it is not expecting it to be a series like this. It was expecting to be in a combination. So for that reason, I have to give a combination command. So C actually makes a combination of these many elements: first column, third column, sixth column. So this is making a combination. Before the comma part, it is my row, and after the comma part, it is my column. So this is the major syntax in R that you need to remember. So I hope it is clear.
Yeah, that helps. Thanks.
Okay. So coming on to this part, so this is actually subsetting my data set. So what it does is brand equal to dominance. It will filter out all the uh, data set which has only this brand name. So if I make a SQL equivalent to explain it better, select star from my orange juice data set where brand is equal to dominance. So this will be my SQL equivalent. So remember, uh, if I make a filter here, I will be making filter in this part. So this part actually shows my column. If I'm so here, I need to filter out my column in the select statement, and in the where clause, I need to filter out my row. Right. Similarly, in R, I would filter out my rows here and column here. So first argument that filter out is row. Second argument filter out my column. If I'm not giving anything here, I'm putting it a blank, then it will take all the rows, all the columns, sorry. And if I'm filtering up my rows, it will filter out these many rows for me. So let us do that. And if I check the summary of that, then I have details of Minute Maid and Tropicana also, but at the same time, these are 0. And Dominic is 9,649. So any reason that why Minute Maid and Tropicana is 0 and not, why not it has been completely removed?
Filtered out for only dominant
because
data.
Yeah, it has been filtered out, but the thing is that there is no brand of Minute Maid and Tropicana, so it shouldn't be there at all.
because your data set still contain Minute Maid and Tropicana, and this is what you are extracting out of that complete data set.
Yeah. Somewhat clear, somewhat correct. Because what happens is, so uh, the concept of object-oriented programming or hierarchy is still there in R. So R follows that. So my parent data set, orange juice, had all these uh, factors of brand, but my child data set is not having, but still it is inheriting the properties of the parent data set. So for that reason, it has inherited those properties, but as there is no value or there is no observation with Minute Maid and Tropicana, it has shown 0. So I hope this makes sense. So let us look at the dimension of date. So as I filter out Dominic only, I'm getting this many number of observation and 17 columns. So here also you can see what are the number of uh, observations and column. So table is also a very good thing. Here also if I check, it has shown Minute Maid 0, Tropicana 0 and Dominic. For the same reason, because Minute Maid and Tropicana were part of the parent dataset, and for that reason it has inherited by the child dataset as well. Now, so here I have OR clause. So let me explain it in the SQL perspective. So, so I would actually ask you to try what would be the SQL equivalent of this code. So it is quite straightforward. Just try to understand and explain me what would be the SQL equivalent.
Uh, it should be the same as the above one, uh, but here uh, should be select star from OJ where brand in Dominic and Tropicana.
Correct. Absolutely correct.
Dominic, comma, Tropicana, yeah.
Yeah, correct. Select star from orange juice where brand in uh, Nick or Tropicana. So this will be my SQL equivalent of this code. Head, as you know, first six, top six, it will show. So what if I don't want top six? I want top 10. I can give that in the argument. I can do it like this, and it will show me top 10. Sorry, let me run this command, and now it will work. So it will give me top 10. And let's say if I don't want top 10, I want only top 4. I can do that as well. So it is, I can set the argument, but by default, it will be top 6. Top 6 by default. Similarly, for table, I find both of them, but not Minute Maid, because I filtered only these two. Similarly, dimension of, if I say, so 9649 rows has been added to my new data set. So previously it was 6000, and now the new data set contains added other brand as well. So again, you can try this out. What would be the SQL equivalent of this code in the comment section? Come on, try. What would be the SQL equivalent of this code?
In a very condition, you can just apply brand is equal to Tropicana and fit
Correct,
is equal to 1.
correct. Same thing. So here now one thing. So uh, this is also the same thing regarding my filtering out of rows. So here I'm making a filter out of Dominic, Minute Maid, and uh, orange juice or featured. So what would happen is, so this will be uh, or on or with this and with overall. So let us see. And if I check the dimension of day one, I have these many. But here, if I put a filter, that means this operation will be done first, and after that, this operation. So if I do this, and then, so I hope what the bracket does is clear. That the bracket actually first makes this subset, and after that, along with the condition, it makes a further subset on future.
You can alter the variables, right?
What?
Like, I mean, if I want to put brand is equal to minute.made and offset is equal to 0 in the first bracket, then Dominic's. I mean,
No, which one? Which line?
so, I want to filter brand is equal to minute.made and OJ fit is equal to 0, then in a
Mm-hmm.
separate bracket,
Mm-hmm.
and again brand is equal to. Will that work?
Yeah,
Here in
yeah,
the first bracket,
yeah.
you are
That will
putting
work. That
both
will
the
work.
conditions of one
Mm-hmm.
variable.
Mm-hmm.
What I'm saying is that
Mm-hmm.
you are putting both the conditions in the variable brand itself first, then you are putting second condition on a different variable.
Mm-hmm.
Can I put different condition on two different variables in one bracket and then put a different condition on
Yeah.
another variable?
See, yeah, that can be done. So you all have heard about that association rule, or you must have done that in your class 11 or 12 in the OR gate, logic gates. So
Yeah.
if I explain that, so A or operator here, and then B, and then an AND operator and C. So I remember that if you change it, it will become something like that. That would imply something like this. So,
Yeah, I got it. Thanks.
yeah. So that will change. So yeah, you can like that, like that also. So that is up to you. So one more thing regarding which. So which actually gives me the index number of the following thing. So for example, let's say I'm declaring a series of vector starting from 17 till 33. So my x contain that, and I want to return only those variable index that are more than 26. So starting from 27 till 33. So my 11 number or element till 17 number element will contain all the true values. So in case if I want to filter out these many variables, which operator can also work. So here also, as you can see, which will give me the index. So if I see the head of index, so where Dominic starts, it has given me those indexes. So if I go to my observation number 221, 221, it will give me Dominic. 222 will give me Dominic, and so on. So this is what which does, which actually gives me the index. So using which I can also filter out my data set. For example, that too, and if I want to filter out orange juice using this and index. So index will filter out all those with Dominic. So you can use it like this, or you can use which here as well. So only mm, need of which would be when you need the index number. Otherwise, there is no requirement of which separately. There would be no need for it at all. Only if you need the index number, then only you should work with which. So subset is also a function in base R. It doesn't require any package. So it will work in the same way as we have done here, the subsetting of variables in the similar way. So subsetting here, let me explain you the command how it works. Subset original data set that I have, and in that data set what I need to subset. Uh, Again, and here also there is one more feature. So if I need to drop any column or anything, I can do that using drop. So this is for selecting the column and this is for selecting the row. So there is a convention in R. Always row comes first, then column, followed by column. So first I need to filter out my row, then I need to filter out my column. And this is how it will work in R. Always remember that. So first filtering out of my row and then filtering out of my column. And if I want to uh, de-filter out some of the column, then I can use minus sign. Minus sign will actually remove those columns or will not give me these columns in my final results. So let us
It's
see.
like keep and drop statement in SAS, right?
It is all like using the drop keyword in SAS.
Yeah, yeah.
Yeah,
Keep and drop in SAS.
keep and drop. Correct, correct, absolutely. So keep keyword in SAS, and here if I do it, so it will be like drop keyword in SAS. So here how it is. So now this is filtering out of column. So always remember where is the comma placed. So based on the position of comma, you have to identify that which feature is getting filtered out. Either it is my column or it is my row. So always remember the try to find the position of comma. As I said earlier, this will be my row and this will be my column. So here I am filtering it out my brand and true feature. Only these two columns that I need at the moment. Unidentified columns tree. It shouldn't be feature tree. It should be only two feature. So here I have filtered out two columns. Now let's say if I don't know the name, I only know the number of that uh, I would say column, then uh, it can give filtering of columns based on uh, index of that column. So let's say which function will work here as well. So which uh, of let's say orange juice, and let me see. So okay, it was not able to find out. Sorry. Sorry. So this is so if I need the number of that column, that or area. So which column number is okay? Okay, let me see how this can. So regarding this, I'm not sure what would be the command for filtering out the column number, but uh, let me see if it can be done. Okay, yeah, I remember now. So it was actually column name, call names of OJ, that will be equal to brand. So it gives me second column. So second column my belongs to brand. Similarly, if I need to know the index number of my uh, let's say feature, it will give me fifth. So fifth column is my feature. So I just forgot this command call name. Then I realized that yeah, it is. So request to everyone, if you're not speaking, please go on mute. Okay. So again the same thing. So here I am dropping these column indexes. So dropping of column numbers from 3 to 5. So 3, 4, and 5 will be removed from the column. So if I see, so brand and all other things which were there previously, those are removed. So so brand was there, week, log, move, and feature. These are the three. columns that has been removed. Again, same thing, the drop function. So here also the same thing, filtering out using my command. So let us move ahead, and so now some of the transformation on the existing column that we have. So for now, let us say if I need to make a log of my column and store it in another column name, I can do it like this. So if I execute only this part, it won't work because there is no vector log inc in my dataset orange juice. So it would give me null because there is nothing existing like that. So now if I need to change that and I need to store what are the log of my income in that variable, it will be stored. So now when I check my dimension, my orange juice has become 18 variables. So one extra column has been added now. Number of rows remains same, but now extra column which contains a log of my income. So this was about creating a new variable in R. Now let's say, okay, so Arun, which part you want me to repeat? Creating new variable. Okay. So let's say, uh, let me give a fresh example and explain. So suppose I need to create a flag, orange juice, a flag variable, a dummy flag variable. So and my flag variable, the condition of my flag variable would be if my brand name is Tropicana, it will give me a flag 1. Otherwise, it will give me a flag 0. This will be my if else condition. And currently, I don't have any such flag variable with me at the moment, and I need to create that. So just give the name of the variable that you want to create. That's it, nothing else. And now, if else. So first would be my if condition. My if condition is orange juice brand that will be equal to Tropicana, and if it is yes, then 1. If it is no, then 0. So let me execute that. So now if I check the dimension of orange juice, I have another variable added, that is flag. And let us check the dataset as well. So towards the end, I have a flag variable which has been flagged whenever I have Tropicana as my brand name. And now if I check the table content or the number of rows there in orange juice flag, so see 0 for this many times and 1 for 9649 times. This is the same number of times that we have Tropicana, right? So this is how it is. Okay. So now something about ordering or sorting. So suppose I have these many numbers with me, 800, -4, 5, and 10, and I need to order them according to ascending or descending depending upon my requirement. So let us see how this works. So what it has done is it has given me the index number. So what is the rank? So let us see. -4 is the smallest number. So it has given it rank 1. Oh no, sorry. This is something else. Uh, Numbers and then order of numbers here. So here it has by default uh, done it in a I would say mm, ascending order. So by default ascending order is equal to true. Just one more thing. Why it is given
I'm
it?
not getting it.
Yeah. Yeah, order should have been different, but okay. So just yes, order is used for sorting. So one more thing here, if I need to make a transformation like decreasing equal to true or false, so if I make it true, so this is my order now. So it has been sorted in decreasing order. By default, ascending order is my default argument, but otherwise I can change the rule. So this is mainly about sorting in R. Though I'm still not clear why it has given the index number incorrect, I still need to search on that because even I was expecting it to be of different orders, but let us need to understand that why it has gone wrong. Or it could be possible because there is not any difference between minus or plus. So let me see that. No, maybe some for some other reason. I need to check on that.
Yeah, Ankit, can I explain these things?
Yeah, please.
Yeah, actually, you created a new variable numbers.
Mm-hmm.
So numbers have a value. First position have a 8, second position is 100,
Mm-hmm.
third position is -4,
Mm-hmm.
fourth position is 5,
Yeah,
and fifth position is 10.
correct.
But in next statement, you have to use order numbers.
Mm-hmm.
So it means it default is sorted this variable
Mm-hmm.
in this number.
Mm-hmm.
But but we only use the order and this variable number.
Mm-hmm.
It will show the after sorting position. So after sorting position means, so default this is in ascending order. So first will come as a -4.
Okay.
So what is the its initial position? So -4 have initial position is 3. So it will show as a 3. And second is second after ordering is 5.
Mm-hmm.
And what is the initial position of 5? So initial position of 5 is the 4. So it will
Oh,
show as a 4.
okay.
Yeah,
Okay.
and after that, next is the according to ordering is the 8. So
Mm-hmm.
what is the initial position of 8? So initial position of 8 is the 1. So cause of that order number it will show as a after sorting the position of the with the respect of the initial value.
Correct. Absolutely. So
Yeah.
let me explain that what Sashi said uh, in just a bit summary. So as he said, this is my first position. 8 is first, 100 is second, this is third, fourth, and fifth. So after ordering, what is happening is my third position is getting first, my fourth position is getting second, my first position is getting third, fifth position is becoming fourth, and second is becoming my last position. So ordering here is only telling me my index number or the index number of that position. So this is what Sashi said just now. So thanks Sashi for correcting me. Even I miss out things at some stages, and thanks a lot for correcting. So this thing I have already shown you that how it works.
Hello, Ankit.
Yeah.
Can you explain me once again that?
Okay. Okay. Sure. So as you can see, my first number is 8. So the index of 8 is 1. Second number is my 100 and index of 100 is second. Similarly for minus 4 third, 5 is fourth, and 10 is fifth. Correct? Till now here no issues. And after ordering them,
Yeah.
so what would be my first index that I after ordering? First number is 3. Correct? My first order. Minus 4 is my first
Yeah.
one. So 3. Then
Yes,
second is
three.
my fifth. So
Yeah.
order of index of fifth is 4.
Yeah.
Correct. After that comes my
More.
eighth.
Yeah.
8. Or let's submit. Yeah. 8.
Yeah.
8. And this is my first. Third position. After that 10th. That is 5.
Okay.
And after that 2. That is 100. So this is what I'm getting here. Got it?
Okay. Okay. Yeah. Thanks, Ankit.
Thanks.
Yeah. Thanks.
Okay, so this is about aggregate function. So mainly in SQL, you must have seen about aggregate function. So there we have few of the aggregate functions. So some of you can name it aggregate function in SQL. So mainly these are minimum, max, like sum, average, and there are many more aggregate function as well. So like count. Some of you would like to try many more aggregate functions that we have apart from this. Standard deviation, yeah. Though I've never tried standard deviation in SQL, but yeah, it could be a aggregate function as well. So here, similar thing with R as well. So here I have my aggregate function and I'm storing it to aggregate. And what is happening is some features that you need to remember in the aggregate function. What would happen is aggregate. First, I into my numeric function, numeric variable. So, for example, if I need to aggregate my name, name cannot be aggregated every time or any time. Aggregation can be done only on a numeric variable. So, you understand that. Suppose I need to aggregate age of every member of my family. So, that is a numeric function, a numeric variable, and that can be aggregated. Similarly, price here is my numeric function, a numeric variable, sorry, and this can be aggregated. I cannot aggregate my name here, so that is a problem. So this is my variable which I will be aggregating, and by what? So I'm aggregating by brand, and here by what, and by which function. Okay, so let me put it in a
By is like a class. Yeah.
class. Correct, correct. In SAS, it would be a class. So I will explain a SQL
Yeah.
equivalent of this code as well. So let us say select. Suppose if I have age or say name, and then I need to aggregate average. Let us not do that. So department, and for that average age from uh, my and dataset file, and I don't have any where clause, so directly group by uh, my class that I have is section. For every department there is a different section, and it will be group. Sorry, this won't be that. I'm sorry. This will be department only. So this has to be same. So first will be my department, and then aggregation of ages or average of age per department. So this will be my command. So let us run that and see what is the result. So prices of the different brands has been aggregated, and the average I'm finding out here for Dominic, for Minute Maid, and Tropicana. Now class of this is a data frame. So data frame, that means if you're not aware of data frame or other classes of R, you can go through my previous videos on R. There I have explained very well what are vectors, data frame. So data frame is mainly a two-dimensional matrix that I can have. So this has a row and has a column, that can be a data frame. Now tree apply. You all of must have done a pivot table in Excel or pivot table in any other tool. So pivot table equivalent in R, for that we have a tree apply. Tree apply means table apply to be aggregated. So uh, tree apply is mainly a pivot equivalent in R for all the, and it comes from the apply function, the family of apply function. So in the apply function family, there are functions like apply, sapply, lapply, and tapply. So mainly I worked with tapply because there was a requirement for making a pivot of the data set. For that reason, I've used tapply most of the time. Apply, sapply, and lapply I have not used much. Even these are used, but not extensively. I have mainly used tapply, and I've always felt that tapply has more, as a better feature of providing me the results in the most aggregate form that I can have. So for that reason, I mainly use tapply. You can go through the codes like apply, sapply, and lapply also. So this will be a homework for all of you. Just go through the functions like apply, sapply, and lapply as well. So let us make a pivot. So here again, I want to tell you what would be the working of tapply. Here is my numeric function. How it works, let me show you. So first argument after tapply, that is my numeric variable that I need to aggregate. Second, on what basis, or mainly class. Third will be my function, right? So let us do that. So here I have. So this is only one dimensional. So all the brand and their averages. So let's say if I want to do it in some other way, not like this, but in a different way. Let's say I want to add some more class to it, some more features to it. What I can do, tab 1 to apply. Again, the numeric variable that I need to have is my price, and now index equal to list. So what it will do is it can take many more parameters less than one. T stands for table, mainly table actually. S can be said as sum, L can be so T mainly applies for table because we are having a table equivalent of all the uh, information that we are processing. So list of, let's say I want to make it on the basis of two variables. One would be my brand and another is my uh, do I have any other categorical variable, or so let's just store, and I want to find out my main. So let us see what it will do. So see, first argument is my row, second is my column. Always remember that. So first argument was my row, so brand was my row, and my column was number of week. Number of week or no store, sorry, it was store. So it has been aggregated on the basis of the brand and the store number. So you see, so mainly it is worked for, so and you can see it is a equivalent of pivot table in Excel or any other tool. A pivot table actually will look like this only. Yeah, correct. So grouping by first brand, then grouping it by another thing, by store ID. You can see first grouping it by the brand and store ID. And similarly, if I make a pivot equivalent, for example, you all must have done a pivot table here. So if I insert a pivot table, there will be some options. So let me go to the data set and explain. Or if I remember if I where I have kept it, then only to explain you better. Downloads. Okay. Downloads. Data set. So orange here I have. So let me insert a pivot table and explain you. So what were the levels? If you remember, my value was price. So price in the value part. My row was brand. So brand in the row part. My column was store. So here I have store. And the function that I have used is main. So let me set the value as average. Okay. So here I got the pivot equivalent, pivot table for same thing. So this is how it works in R as well. So for R you have just where it was, yeah, here. So this was it. So hope it makes sense now. and there shouldn't be any doubt. So is it clear or any other doubt? This. Okay. Okay then. So simple merging statement in R. So here I've created a data frame. In this data frame, my customer ID is so, and my product, and every customer ID has a product for it. So let us see what is there in my data frame. In data frame, I have customer ID and product, and the product that are associated with each customer ID. Similarly, I make another data frame here, df2, and in df2, let us see what are the uh, elements or information that I have. So here I have customer ID and with state. Now I wish to join both these, uh, I would say, a data frame into one. So mainly I am looking for merging, and merging here is as easy as merging in SAS. So just a simple command. And also one thing that you need to take care in mind before merging, that like in SAS, both the dataset names should be same. Specifically in data step merge. In SQL merge, if it is unequal also, it won't create any issue. But specifically if I am looking for data step merge, then it has to be same, right? So let us proceed with that. So for full join, this is what simple command step. Simple. X will be my data frame 1, Y will be my data frame 2, on what basis or what variable I'm able to join them, and is it a full join, left join, right join, or only inner join. So this argument, if all equal to true, then full join. If x equal to true, that means x is on my left side, so it will be a left join. If y equal to true, then it would be on my right side, so it will be a right join. If I don't give anything at all, then inner join. So let me see what are the results for full join. So in full join C, all the customer ID has been included, irrespective of what was there in right side or left side. All the customer ID has been included. Let's say if I need only left join, or what was there in the left hand side, or what was there in X, uh, and what is common there. So everything in X and what is common with Y. So this again, you see some missing values here. Everything in X has come with some missing values in Y. So everything from Y and something missing from X, or which is not there in Y from X. So everything from Y has come up, but there are some missing values in corresponding to that customer ID. So for that reason, we have some missing value here. And let's say inner join, where everything common has to be included and everything else apart should be left off. So this. Anti-join, so I'm not sure if anything apart from that. Anti-join, I'm not sure. So anti-join, what it does, uh, so I think there was a command in SAS for, I think, not exist, correct? For not exist, I'm not sure if it works or not. For not exist, I have to check accordingly. I think you are talking about that only, right? Not exist. Then No, so I'm not clear about the concept of anti-join, left anti-join. No, I'm not clear about that. So not exist I have done, and I think as a part of SQL-df package that we have in R, we will be able to execute non-existing command here as well. So, but regarding not existing command here in merge statement, I'm not quite sure about. So, in the SAS session, for all those who have attended, there was a part of not existing in that was taught in SQL. So, not exist mainly filters out those part which doesn't exist in another data set. So, SQL-df is a similar package in, I would say, so let me. So SQL-df mainly, so like we have proc SQL in SAS, so where you can work with all the SQL statement. We have a package here, SQL-df in R, where you can work with SQL command and you can get the output accordingly. So for example, if I'm more comfortable in SQL and I want a SQL equivalent in R, I can do that. So uh, one question to all of you. So if I need to select top 10 observation from a data set, how can I do that? In SQL, top 10. Row number, yeah, limit, and also top 10 was there, na? Top 10 like this. Okay, so it was,
It is still loading, I guess.
no, because it is still loading. Let me check. Because it was already there. And I remember I have installed that package. So star will be from, I think, so what is the right command? Anybody remembers that? Or the top comes at the
Select top and start.
top 10 star. So previously I did that, but top 10 star. Okay, so let me see if limit works here. Because even I'm not sure which part of SQL it works. If it is MySQL, yeah, limit is working here. So limit works. So any SQL thing that you need to work on, you can work with SQL-df package here, and it will give you the same result. So in case if you find that you are more comfortable with SQL compared to R command, you can use that. And also because I've been working with MS SQL Server, not with MySQL. So in MS SQL Server, I think top was the command that was used, and in MySQL, I think it was limit. So for that reason, there is a bit of mismatch there. So one more important package is Dplyr. So Let me install that. And so previously, as you remember, we have done a structure of orange juice. So in structure, I was getting a um, good summary of all the things. For that, we have a Dplyr equivalent. So glimpse is Dplyr equivalent for structure in base R. So it will give you the same result, but with more number of features or a better elongated or more detailed version of structure. Now, in filtering out in or subsetting of the data set in base SAS, we have seen the command, and that was a bit different. And here it is a bit different. So if we go back to the top and if we check, so it was something like this: subsetting of row and then followed by column condition. In Dplyr, we have a different condition for filtering. So filtering of orange juice dataset on the basis of the brand that I have. So let us do that. So there were lot many number of rows, so it has limited itself because there was no space to print all of them. So what I could have done, that I could have made only head of that, just to limit till 6. So only Dominic has been filtered out. Again, same thing, filter dataset name and the condition that you need to provide. And here again the same thing. So let me make a comment to make explain you better. So here I have filter, then it is followed by dataset name, then followed by my row condition, row filtering, and then followed by my column condition. Right. So this is how it is. Let me again. I could have given that head only. So now coming to n operator. So here in n operator, pipeline is for or condition. So here it is similar to the in condition that was there in SQL. So my brand in so and so. So if my brand is so and so, it will filter out my all the uh, in orange juice. Similarly, if my brand is Minute Maid or Tropicana, it will filter out. Now ethnic between. So all of you must have, if you remember, there is a syntax in where uh, ethnic between 1 and 2. So this is the SQL equivalent of that code, where my variable between this and this. So similarly here in filter as well, I have my ethnic between point 1 to point 2, and it will be inclusive of both of them, inclusive of 1 and inclusive of 2. Otherwise, I can do it like this as well. So this is my same command, but has a different equivalent. So it is greater than equal to 1 and less than equal to zero point 0.2, uh, zero point 0.1, zero point 0.2. Here also, just to not to confuse you, I will do it. And here is not dot .na. So in R we have something like logical functions like is dot .na is uh, is actually a check. It will check that if my variable has a null value or not. So on basis of that, it will give me a true value or a false value. Similarly, if I have something like not is dot .na, that means it is checking if it is not. So it is checking if yes, it has a null value, and it is checking if not, it doesn't have a null value. That means it has a proper value and it has a null value actually. So for this, if there is a null value, it will show true, and if it has a proper value, it will give it true. So here I will find all the values of workworm where it is not null. So all the not non-null values will be filtered out in orange juice new. So now if I say, so this is slice. Mainly that we have done in uh, filtering out of rows. So this equivalent in base as the command would be orange juice of 1213 till 1218. This many number of rows. Oh, sorry, this many number of rows. This shouldn't be column. So I'm filtering out this many number of rows. This is uh, this is how slice works. Now sample. Sample is mainly sampling of 12 values. So number of values that I need to take. N means that number of observation. So out of the total observation, 12 samples I want to take. And this is how it will work. Now in case, if you don't know what is the data set, excuse me, if you don't know what is the data set size and you need to make a fraction of it, then you can use this command. This will actually take a fraction of that data set, fraction of 10%. Again, top values. So
So Ankit, will the sample will be taking the random or it will be something on basis of something?
yeah, it will be completely random. So
Okay.
in there are two things in base R also. Without any package, there is a sample function as well, but there you need to set a seed. So set dot seed there works, and you need to specify the seed value. So anything you can write it there, and then you can make a sample of that. So this is in base R, and this sample frac is in Dplyr. So understand this. So sample, so your data set that you want to make sample, and then on what basis, replacement equal to true or not, and the size that you want to take. So setting of seed will actually make a sampling pattern. So setting seed or this number has nothing to do with any of your sampling thing. It will only define a sampling pattern. right?
Okay.
Okay. So let's say, just for an example, if I take sample 1, so if I have it like this, 8, 6. Now if I set my seed, and now I'm taking a sample, now 6, 9. So the pattern is fixed when I set a seed. Apart from that, it has nothing to do with any other. So this is same as the select statement that we have in SQL. So brand, income, and features. These will be selected. Just not to make it a big data set, or I am limiting it to 6 only, or by default it is 6. So only these many columns are selected. Again, same thing for this also. So here also, these columns will be omitted, drop. So this will be equivalent of drop. So this is actually keep, and this is drop. So all the column names are there except these. Okay. And here, starting from week till price, all the columns will be selected. Starting from week, and so here also let me give head. So in between week and price, I have 2 columns. So all these 4 columns have been selected. Similarly, here I have contains SSTR. Select orange juice, which has a this regex, or this part of the string is there in that uh, column. So again, let me do it a head. So SSTR were there in 2 columns, so it has filtered out them. So this is filtering the basis of uh, contains or like. Now start with also you can. So if a column name starts with so and so word, you can also do that. Ignore dot case will actually set you if you want to is it a case sensitive or not, the search. So as you remember, there was a find function in SAS which has an option of case sensitive or insensitive. So if you have specified an I there, then it would have become sensitive, I think. So the same option here as well. Ignore dot case equal to true or false. So find was mainly to find the index of a word there in SAS. Here again end with 0, and here if I so ignore case, here also I can give it a true or a false depending upon what I. So again I should have selected only head. Okay. Yeah, it is only specific for column names. So I'm filtering out these column names. So it could be possible that on any day I have 100 of columns and I need to filter out those columns. So this could be my command. to actually extract those column names. No, no, not row. So row filtering. So row name is also there in R, but that will be that we will take, but later on. There could be row name as well. So just to let you know, for example, where we have column names, similarly we have something called row names as well in R. So this thing comes into picture when we have some such kind of data set. So we will be working with that soon. Similarly, this as well. So if it contains C and W, ignore case. So I have a lot many things. So week, price, C, C, C here, C here as well. W, C here as well. C and W both. So it has filtered out all the rows with C and W. So now this is 0 to 9. So any match between with any integer, presence of any integer there in the column name will be filtered out. Again, let me make it a head only, not beyond that. Mismatch in the head. So all the numeric one have been filtered out. So every column which has a filter, which has a numeric with its name, has been filtered out here. So rename also. mm, for that, so I've not taken a let's say another equivalent for that. So let's so for example, I have column names of orange juice. I have these many column names, store, brand, and so many. So, for example, if I want to change brand to capital brand, so uh, how I can do is out of these many column names, I want to filter out first my brand, and brand is my second column name. So in column name, second one. Now I have brand, and I need to change it to some other variable name, that is brand. So this is how I can change. Now when I check my column name of orange juice, so see all of so brand has been changed, right? So this is how it works in base R functioning without any packages. Now if I am taking use of any package and then I need to change, then let's see how it will work. So first let me change it to the previous value brand. Now let's it has been changed. So now rename. So I don't think we have any column name with zone. So let me flag. Let me change flag. Oh, sorry. It will be the other way around. It will be the other way around. So the one, so previous value, then new value. So just to make it clear, orange juice. So this is my new value equal to previous value that I had. Okay, so this is how it is. So it will be new value, then followed by my previous value that I have. So flag, if you remember, in the beginning of the class, I created a variable of my own that is flag, and now I'm changing it to zone. And now if I check, so last column, it was my flag that has been changed to zone. Now mutate is another option that I have. So previously, for making a new variable, what I did, you remember, if we started with log of income. So there, if you remember, I've changed the where it was, yeah. Okay. So I've taken the log and then I've changed it to log of income. So similar thing can be done in Dplyr as well, Dplyr package, and that is a very easy command for that. So just mutate. With mutate option, you can change from that function, applying that function to the new variable name. So here you don't need to write that dollar sign. So just provide this log of income with log, the function that you need, and then followed by the function name. Sorry, the variable name and the function. So when I look at the glimpse, that my last column name is now log of income. Now you see all the options are same. So it will be actually corresponding to income only. So if it is all same, then yeah, the log of that value, and it has done with base value of log with uh, exponential. So ln, natural logarithm. So now if I need to change the base of the log, so if I need to change the base, I can put it as 10. So now the logarithm will be done on the basis of base 10. Now if I see, so the value has been reduced. Okay, so this is how it works. Now similarly, I have another option of mutate each. So each mutate is will actually mutate all the column names that I have listed out so far. And function I need to declare that on which basis the mutation will be done, or that new variable name, on which basis it will be listed out. So here I have mentioned in my dataset orange juice, and then function that is main that will be applied on existing variables that I have listed so far, and with a new variable name. So for suppose if I have uh, many variable and I need, the same transformation need to be done on all the variable. So this is a very useful command for that. Okay. So, now similarly same thing here as well. Square root and log. So here I am using two transformation, square root as well and log as well. And now let us see what happens here. So see here towards the end, I have got square root of income, square root of age, square root of ethnic first, and then log of all these. So this is how mutate each will work. First I've listed out my data set, then my functions that I need to apply, and on top of it, the variable name that I have. So by default, it will create its own name. Here I was specifying the name, but for suppose if I don't have that, I don't want to type it for so many times. I can only give the function name and the variable that I need to make the transformation, and I can do that. So both are actually same thing. Mutate will actually do one at a time. Mutate each will make the transformation for all the variables that I listed out so far. So mutate can work for only one variable here. Let's say income. It can work for only one variable, but mutate each can take many variables at the same time. So this is the only difference. So if you want to make a transformation in many variables at the same time, mutate each is a better option.
Yeah, Ankit.
Hmm. Okay.
Yeah, actually, I face one problem
Hmm.
in the mutate each.
Hmm.
So when I use in the function,
Hmm.
so that time it will not work. This type of commands are not work in the function.
Hmm.
So that time I use a lazy function, some lazy package.
Okay.
When I apply a lazy package
Hmm.
with the mutate each,
Hmm.
then it will work in the function.
Okay. So any reason that why it is not working? Because uh, uh,
When these conditions are only applicable for when I use in the function.
okay.
So
Okay.
that time, you can use the lazy package.
Okay. Okay.
Yeah.
So even I was not aware of that package. So until now, I've only used mutate function till this time. So thanks, Shashi, for adding that. So here we have transmute function as well. Uh, so unlike the one in mutate function, so transmute will work for so in the same way, but the only thing is that if I don't want all the columns, so for example, here in mutate function, what it has done is it has given me a list of all the columns that were there in the data set. Uh, Apart from that, which were existing there, and also which has been added recently. But in case of transmute, what I can do is, if I need to make transformation on only one column, and I need to show you only that, then transmute works there. So Murthy, are you still not able to hear me?
Ankit, can you explain the transmute function again,
Okay,
please?
okay. So here in mutate, let me show you this. So uh, let's see. So in mutate, as you can see, I've got all the column names that were there. So after adding the new column to the data set, it has added to the entire data. But in transmute, what happens is I have only one column with me. So only one column has been added, and I can use it separately, not as a part of the same data set. So this is the only difference. It will also make the same transformation, but only thing is that it won't add it to my data set. That's the only difference.
Okay.
Okay. So arrange also works in the same way. This is mainly on sorting. So sorting of my data in Dplyr package. So arrange on the basis of income. So it will arrange in the, so if I check head of so it has been sorted out in the basis of income in the ascending order. So if you remember, my store started from 2, but now it has arranged it in a different format, starting from the minimum value of income. Similarly, if I want it in a different order, I can give minus sign. Now, with my highest income to the lowest, it has sorted in a descending order. Now, again, if you don't want a minus sign, you can write it like this, descending or ascending or so on. And also other arguments as well, you can pass it for this, for sorting of your data set on the basis of the variables that you have listed out so far. So this will also work in the same way. Head of orange. So here, the descending order. And now here, when I do it, it is done on the basis of 2, income and week, both as well, both. So week is also the same and income also. Uh, sorry, this will be there 4. Yeah. So here is my week in the descending, starting from the highest, and then income, starting from the highest to the lowest.
Ankit,
Mm-hmm.
whatever the results which you are showing on the console,
Mm-hmm.
can this be viewed as a different as a table?
Yeah. So view as
How do we extract?
table. You can use this view option. So there it is. Or what you can do is you can simply click here. So the data set which you want to view, you can do it like this. Select it and it will show you there. So is it fine?
Yes, yes, it's
Okay.
fine.
So take.
Yeah, Ankit.
Mhm.
Yeah, maybe this statement is equivalent to in SAS
Mhm.
by descending income during week.
Yeah. So in SAS there will be 2 equivalent. One would be in proc SQL, which you all must be knowing that
Yeah.
in the order sign. So order by my so, like proc SQL, order by uh, let's say income, then BSC. Or in the uh, statement of that sorting, I can do it by proc sort. So proc sort, there will be an option there. So now trailing with the missing values. So I know it's quite a lot of time, but few more minutes and then we will conclude. So, treating with the missing values. So, uh, here I have some missing values in the vector that I have created and how we can treat that. So, let us work with that. So, I have created all the, I've just created a data vector and I have passed all the records into A. So let us see now what is there in is.na. So is.na is a check whether it is a null value or not. So first six values were not null. For that reason, for first six values I'm getting false. And after that three values are null. So for that I'm getting true, true, true. And after that there are not null values for which I'm getting false for everywhere. Now sum of is.na will give me how many values are actually false or how many all null values are there. So there I have 1, 2, 3. So three values are null and for which it will give me 3. Correct. So this will give me, so this is mainly summation of number of null values or summation of non-null values. So one new thing. So if I want to make a main of my entire vector and I have missing values here, I can give an argument here as na.remove. So after removing all the na values, it will give me the main. But if I don't do that, and if I'm doing it only by making a, so it is giving me a na value. Now if I remove that option, or sorry, if I add that option of removing of null, and if I check, now it is making a sum of or actually mean of all the values that I have, omitting the null values. So null values are removed, and on the basis of the values that I have remaining, it is making a main. So what I can do is I've stored my main value in M, and I am replacing all the NA values that are there in A with my main value. So if I check what is there in my A, so all the missing values has been replaced by my average values. So this is one of the way you can treat the missing values if you have in a data set. So this is one of the most actually the most widely used method for treatment of missing values. Also, it also depends upon your type of data set that you have. If it is a right skewed or left skewed, then main value might not work. You have to consider some other values for that case. So right skewed or left skewed, what is that? I will come to that. But if your distribution is completely normally distributed, then mean is a good option to take in that case, because in that case what happens is your dataset doesn't deviate much from mean value. So taking a mean in that case would help. And now next step about data manipulation or string manipulation mainly. So suppose I have a string called Batman here and I'm assigning a to that value, and let's say I'm doing a substring now. So SAS equivalent, if you all can say what is the SAS equivalent of substring, I think it is same. So anyone with SAS equivalent of substring?
Have a substring function in SAS as well, right?
Yeah, correct. It is same. So same in SAS as well. So it will start from some value 2 until sixth value. So I've got at man starting from this till end of this. Number of character of A. So there in SAS we have the length function which will give me the length of the character, but here I have nchar. Nchar is 6 for Batman. And length if I take, so what will be the output here? Anyone wants to try? This will be an interesting one.
default length for a string value?
Okay, so nchar actually has taken the care of length of that string value, but what length will do? So here, just to surprise you all, length will be equal to 1. Why? Because I have only one string. If suppose I had a combination of many strings, let's say combination of so, and now if I take length of b, it is giving me 3. So it actually tells me how many strings are there, how many independent strings are there in my uh, set or my variable, as you can see. So length for a will be 1 here for obvious reasons. Two lower, as you know, it will convert it to lowercase. Two upper will move it to uppercase. And here I have str split, something called str split. So if I want to split it on the basis of some, I would say delimiter or any other special character, I can do that using str split. Now same thing, str split on the basis of slash. So it has split it as bat and man. Now the class here is list. So this become part of list. So this is my first list, and in that first element, second element, third, fourth. So like this. Now here I have Batman, man, cat, and here in C I have bat slash man. And if I want to concatenate, so this is mainly a concat function, concat equivalent of SAS. So this will be a concat function, concatenated at the, but there is a trailing or space in between. So concat in SAS, if I remember, the equivalent in SAS was catex function. Uh, cat family of function, or cat, cates, catex. So these were the functions for pasting. Now, as a separator, if you remember catex, you can define the separative part, which with which string you need to separate that. So here I have made the separative part as double question mark. So double question mark, it has been separated by double question mark. This is B and this is C. Okay. So this was part of my till now concat and string split. So let us do some search. So suppose I have a vector of names with me and I want to search something.
Question: how long are you planning to continue? Like
So
this?
it will be 10-15 minutes more, not more than that.
Okay, fine. Good.
So this is grep. So if any repetitive pattern is found with A in the name, it will search for that. So in the first and third element, it has found A, capital A. Now if I make it a small a and then search, then in second and fourth, it has found a small a. So these search are case sensitive. So ignore case, you can always provide that as true or false in your search pattern. So if I do that, so in 1, 2, 3, 4, all of them I have found that A is present. irrespective of the case. Okay, and G grep and let me see. So mainly it checks whether if this character is present or not. So mainly checks the presence. Now, if I have a cat slash man like this and in back, so there's so entire string doesn't match with the previous string that has been provided in the argument. So it is giving me false. So let us do that. Let us proceed with some other function. So sub is mainly a replacement function. It will find the first occurrence and replace it by another string. So here I have dash 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 here, and I want it to replace by slash 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 in between. So sub function will work here. So it will only replace the first occurrence, and if suppose I want to replace all the occurrence, then I have to use g sub. For that I have g sub function. So that is there. Let us come to that also. So first occurrence of slash, and that has been replaced by here as well. Now all the occurrence, then g sub here. So one more thing regarding trimming of spaces. So if I have both the spaces in both the side, in the front, left side, right side, both the sides, and I want to trim them. So what I can do is, uh, first of all, if I want only right side, I can make it like this. So right part of the blank has been removed, or white spaces has been removed. If I want to remove left side, I can remove it for the left side. So this part is now has been trimmed out, and this part is remaining. And if I want both the sides, for that both. So this was about trimming of spaces. I know I'm moving a bit faster, but few more things, then we will conclude. And also, I think I've exceeded the time limit also. So something with dealing with dates. So I have a data set here which has some date formats, flight delays. Mm, okay, I've removed that. So let me see, that is there. Okay, so I think that data set is not there at the moment. Anyway, I'll share this code with you. So let me just explain what it is working with and how the things are working here. So here mainly I wanted to cover a function or a package in R which works well with date. So if you are facing any problem with dates, you can install this package and it will work quite well. So here I have lubridate package in R. Lubridate will actually spot the date uh, pattern if you have in any of your variable, and it will change it accordingly. So for example, I've just identified that my date looks like this. So for suppose my date is 2017, followed by a month, November, and then followed by my date. And on top of it, I have my hours as well. So hours is 12, 8, and seconds also. So you just need to spot that. If you have a date in this format, what you can do is you can put this function there, ymd underscore hsm. So lubridate has many more such functions like if I ymd, let me type the lubridate. I need to install that, so it will take a bit of time. No issue. So code is already there. What you can do is you can go through this code and you can understand. So this part I'm not taking. I want all of you to follow this and work on this. So search a bit on lubridate. I will be providing the dataset that I have here, flight delay. So as a homework, I will expect all of you to work on this dataset, flight delay. So this is very simple, and codes are also pretty straightforward. You don't need to. There's nothing much complicated about the code. In case you face any issue, you can get back to me anytime. But here things are quite self-explanatory. So this part, just few lines of code, I'm leaving on to you. Can make your own Google search, or you can make your own R&D, and you can get to a conclusion, or you can find your own way how to deal with dates. In case if I get some more time next day, I will go through it, or I will take that up in the next class. So that's all for today. I'm ending here. So any more questions or anything apart from that you want to ask, then you can. Otherwise, we are good to wrap up.
Thanks, man.
Okay, thanks, Ankit.
So thanks everyone.
Thank you, Ankit. Thank you, sir.
Thank you, Ankit.
Thanks and
Thank you, Ankit.
bye. And meet you tomorrow. So tomorrow the session will be at same time from 10.
Yeah,
Tomorrow I will be covering this data visualization part.
good.
Okay.
Okay, okay.
Okay.
Uh,
Bye all.
sure.
Thanks. Thanks for attending the meeting.
Bye.
Bye.
Thank you, Ankit.
Thank you, Ankit.
Thank you everyone.